And now we reach the place where we most often run into complex numbers, which is in the quadratic formula. Here we have a quadratic equation in standard form. And we know that the stuff on the left is equal to 0 on the right when x is equal to this result. This is something that we simply have to memorize because it could come up not just with quadratics but with polynomials of higher powers too. It certainly comes up a lot, and so you're going to see it here and in calculus. The stuff under the square root is called the determinant, and we'll talk a lot more about that in the next in 2.2. Meanwhile, in 2.1, we have a quadratic equation to solve. We have to have 0 on the right to solve it at all. Now, I'm going to write down my A, B, and C. I always do. And I always write down the quadratic formula too. The reason why is I make so many mistakes when I don't write it down that I find it much easier to have the stuff that's going into my template and the template right here so I can just read them off and plug them in. So I'm sure you've all done calculations similar to this before, so I don't want to take a step-by-step through the calculation. The one thing that I do want to draw your attention to is that we're going to have a negative number in the square root here, which means we're going to have a complex number. Every time we have a negative number in there, we get complex solutions because of both the plus and the minus here. And specifically, we get complex solutions that occur in a conjugate pair. If we get any complex number, we get two complex numbers. And those two complex numbers are related to each other. They are a conjugate pair. And if you look at how the quadratic formula is built to begin with, then you can see that that's going to have to be the case. We have a constant here and plus or minus the same imaginary component. So a little thought tells us that that's not really a surprise. We're going to see a lot more about this in the next unit, 2.2, and we're also going to see where the quadratic formula comes from, which is very cool. Our book doesn't mention this here, but you can also solve many quadratic equations by completing the square. So in 1.9, completing the square was discussed, and I hope that you have tried some samples of it. Personally, I find it ordinarily more easy to do than using the quadratic formula. Here goes. And observe that I wind up with exactly the same answer before, but I'm not doing so much number crunching, which suits me fine. Observe when I take the square root of this expression, I get the absolute value here, and when I take away the absolute value, I get a plus or minus on the other side. The thing here that makes this work is that I break up the original expression so that I have a perfect square. And then whatever the square root of what's left is, it can be positive or negative. The what's left can. I don't really care, because I'll take the square root of it whether it is positive or negative. And there I am. That's my idea of fun. What's yours?